Skiing is a recreational activity and competitive winter sport in which the participant uses skis to glide on snow. Force, acceleration, gravity, and friction all affect the sport of alpine skiing. A force is a push or pull upon an object resulting from the object's interaction with others. Forces only exist as a result of an interaction. Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity or speed. Gravity or gravitational forces are forces of attraction. Every object in the universe that has mass exerts a gravitational pull or force on every other mass. Friction is a force that holds back the movement of a sliding object. You will find friction everywhere that objects come into contact with each other. Newton's first law states that an object in motion will stay in motion, and an object at rest will stay at rest until acted upon by an outside force. This is what makes it possible for a skier to go down a hill without stopping. The gravity is what puts the skier in motion, and the skier will not stop until there is enough outside force, either by friction or an object, to counteract the force of motion. Newton's second law states that force is equal to the mass times acceleration. Newton's third law states that for every action there is an equal and opposite reaction. It is because of this, when we push off the ground with our poles, we go forward. In a sense, the ground is pushing back.
Jordan is skiing down a slope that is 37 degrees above the parallel. She is accelerating at a rate of 0.27 meters per second squared. If Jordan's mass is 55 kilograms, what is the force of friction opposing her motion, and what is the coefficient of kinetic friction between her skis and the snow on the slope? We are given that Jordan's mass is 55 kilograms, the angle is 37 degrees, and her acceleration is 0.27 meters per second squared. We need to find the force of friction and the coefficient of kinetic friction. Our drawing shows Jordan moving down the slope at a 37-degree angle. Our free body diagram shows the frictional force parallel to motion but in the opposite direction, the normal force, which is perpendicular to motion and moving through the object, and the weight force, which is directly downwards and at a 37-degree angle off the y-axis. We know that the sum of the forces in the x direction is equal to mass times acceleration in the x direction. Likewise, the sum of the forces in the y direction is equal to mass times acceleration in the y direction. In the x direction, the force of weight times the sine of 37 minus the force of friction is equal to mass 55 kilograms times acceleration, 0.27 meters per second squared. By substituting mass times gravity for the force of weight, we get the force of friction equals 309.52 newtons. In the y direction, the normal force minus the force of weight times cosine 37 is equal to mass 55 kilograms times acceleration, which is 0. So the normal force minus the force of weight times cosine 37 equals 0, and the normal force equals 430.46 newtons. The force of friction equals the normal force times the coefficient of kinetic friction. Therefore, the coefficient of kinetic friction equals 0.719. The force of friction on Jordan is 309.52 newtons, and the coefficient of kinetic friction between her skis and the snow is 0.719.